Welcome to This Explainer. Okay, I want you to imagine waking up tomorrow morning, stretching and looking out your window. But instead of seeing your familiar street or neighborhood, you are staring out at an endless, frozen, red desert. Now, while that image has basically always belonged in science fiction movies, space agencies and private companies are literally building the architecture right now to make that exact view a near-future reality. We are standing right on the precipice of a monumental leap for humanity. And that brings us to the core question we're tackling today. What if you lived on Mars by 2035? Global space organizations are actively targeting the mid-2030s for the very first crewed missions to the Red Planet. They want to establish a permanent foothold and push the absolute boundaries of human exploration. It's a highly calculated, incredibly complex endeavor, and while the technical hurdles are frankly mind-boggling, stick with me through this explainer because the single hardest challenge of actually living on Mars is something we're going to reveal at the very end. And I'll tell you right now, it goes way beyond rocket science. So let's jump into Section 1, the journey to Mars, leaving Earth behind. You see, surviving the Martian environment is really only half the battle. Surviving the actual trip there is our first monumental hurdle. Based on the realities of orbital mechanics, the journey between Earth and Mars takes roughly 7 months. So to put that into perspective, imagine a road trip that lasts over half a year, but you're dealing with the immense psychological weight of being confined to a compact capsule, surrounded by a lethal vacuum. As you travel millions of miles through deep space, Earth is going to slowly shrink behind you until it's nothing more than a tiny pale blue dot in the blackness.
This transit basically relies on 3 highly dangerous phases. Step 1 is the launch, which demands massive thrust just to break free from Earth's gravity well. Step 2 is the deep space transit. During those 7 months, astronauts are going to be continuously maintaining complex systems while navigating the very real threats of sudden solar flares and micrometeoroid impacts. And finally, Step 3 is the Mars landing. Plunging through that thin Martian atmosphere and decelerating a massive payload safely to the surface is a total engineering nightmare. In fact, engineers often refer to this part of the mission as the 7 minutes of terror.
Moving on to Section 2, your first Martian day, touching down on the Red Planet. Imagine strapping on a pressurized spacesuit, waiting for the airlock to cycle, and stepping out onto an alien world for the very first time. You're stepping out under a dusty, pale red sky, but the real shock is actually going to be physiological. Mars has only about 38% of Earth's gravity, so your proprioception, your body's natural awareness of space and orientation, is going to be immediately thrown off balance. Every single movement you make is going to feel entirely different as your body tries to adapt to this drastic reduction in gravity. Honestly, walking won't even feel like a normal gait anymore. It's going to feel more like one small step, one giant bounce. You'll literally bound across the surface, feeling incredibly light. But once the initial fun of those altered physics wears off, a very stark reality is going to set in. As the sun sets on your first day, the environment turns incredibly hostile. Nighttime temperatures plummet all the way down to minus 100 degrees Fahrenheit. So finding a highly controlled, pressurized shelter to survive the night isn't just important, it becomes an immediate life-or-death necessity. Which leads us perfectly into Section 3, building a safe home, surviving the elements. Now, the freezing temperature is just one variable. Mars lacks a global magnetic field, or a magnetosphere, and it has an incredibly thin atmosphere. Here on Earth, our magnetosphere acts like this giant invisible shield against cosmic radiation. Without that shield on Mars, the surface is constantly bombarded by invisible energy from the sun, like galactic cosmic rays and solar particle events. Because of this, any surface habitat is going to need advanced radiation shielding. We're talking about using incredibly dense materials, or maybe even building our bases underground inside ancient lava tubes, just to protect the crew's cellular DNA from long-term damage. Establishing life support means we have to rely heavily on something called in situ resource utilization, or ISRU. Basically, we have to use the local environment to survive. We'll literally need to manufacture breathable oxygen directly from the carbon dioxide-rich Martian atmosphere. And incredibly, this is a process that's already been successfully demonstrated by the MOXIE experiment on the Perseverance rover. As for water, we'll deploy automated systems to mine subsurface ice deposits, melt it down, and relentlessly recycle every single drop through a highly efficient closed-loop system. We cannot waste a thing.
All right, Section 4, Daily Life and Dangers, Working on a Hostile World.
Working on a hostile world also means dealing with a massive communication gap. Unlike the instant texting and internet we take for granted here on Earth, data transmission across the solar system is strictly bound by the speed of light. Depending on where Earth and Mars are in their orbits, you're looking at a communication delay ranging anywhere from 4 to 24 minutes. Just think about that. A simple message to mission control could take up to 24 minutes to even arrive, and then you have to wait another 24 minutes just to get a response. Because of the extreme environment, your daily routine will be meticulously structured around colony maintenance, scientific research, and sustaining your biological health. And amidst all the science and system checks, there is one activity that is absolutely non-negotiable: rigorous exercise. In a 38% gravity environment, astronauts face rapid bone density loss and severe muscle atrophy. To keep your skeleton and muscles from basically wasting away, you are mandated to do hours of intense physical training every single day just to remain strong enough to function.
And this brings us to the ultimate test of endurance and the answer to that question I posed at the very beginning of this explainer. You have invisible cosmic radiation, massive global dust storms, freezing temperatures, and strictly limited supplies. But the absolute hardest challenge of all? Extreme loneliness. The psychological isolation of being millions of miles from Earth, confined to a small, enclosed habitat with the exact same few people, unable to ever just step outside and feel a fresh breeze. That profound mental hurdle is going to test human resilience like absolutely nothing else in our history.
Which brings us to our final section. Section 5, a multi-planet future, the year 2035 and beyond. So why do it? Well, the overarching objective of going to Mars goes far beyond simply planting a flag and taking some cool pictures. Becoming a multi-planet species, actually living and thriving on more than one planet, represents a profound existential shift for humanity. It acts as the ultimate insurance policy for Earth's biosphere, basically ensuring the survival of human consciousness. Plus, the sheer difficulty of establishing a permanent settlement there is going to drive massive technological leaps in things like energy generation and sustainable agriculture that will inevitably benefit all of us back here on Earth. Transforming this wild concept into reality requires a very methodical timeline. In the present day, orbital and surface missions are already mapping out resources and characterizing the Martian environment. In the near future, we have to finalize the development of heavy-lift rockets, deploy autonomous robots to pre-build our infrastructure, and perfect those closed-loop habitats we talked about. All of this groundwork is steadily converging on that critical target window around 2035 for the very first human landing, carefully balancing our bold ambitions with strict engineering realities. And that brings us to a powerful quote that perfectly summarizes our source material today. It could be one of humanity's greatest adventures or one of its hardest challenges. I just love this because it so perfectly distills the reality of the entire endeavor. It is going to be incredibly difficult. It will be completely fraught with risk. But if the engineering and the human spirit hold true, the very first people who will eventually call Mars their permanent home might already be alive right now, walking around on Earth today. Which leaves us with one final provocative question to think about. Considering everything we've just covered, the agonizing 7-month deep space transit, the constant threat of radiation, the weird gravity, the profound, inescapable isolation, but also the incredible historic opportunity to establish a brand new branch of human civilization, would you move to Mars if you had the chance? Let us know what you think in the comments. Thank you so much for exploring this absolute frontier with me, and I will see you next time.